Okay, vô đi.
Hi teachers, on behalf of group 8, and today I want to show to the teachers about my old project study from the basic concept and computer evolutions, and go to the introduce about my group. My group have four members. First Nguyễn Tấn Tài, the second Nguyễn Hữu Tô Hoàng, third Nguyễn Minh Nhật, and the last is Nguyễn Viết Chiến Thắng. It's me. And I am the Nguyễn Viết Chiến Thắng. I'm a student of class 24 AI, and I want to show you the teacher the first question that what is the difference between computer organization and computer accuter. A computer accuter refers to the attribute visible to according to the slide. Computer accuter refers to the includes the instruction set, the number of bits used for data types. One is zero and memory abstraction technicals. These elements affect how software is written and optimized. In contrast, computer organization deals with the physical implementation of the attributes such as how signals are controlled, how interface work, and how memory and processor interact at the hardware level. While Accuser remains the same across model for compatibilities, the organizations may differ to ensure performance to reduce cost. And next, what are the key structural components of computer and their corresponding functions? A computer system hierarchical and composed of integrated subsystems. The circuitry refers to how components like CPU, memory, I/O system interconnects are arranged. The functions refer to what a computer a component does. The four key functions are data processing, performed mainly by CPU, especially only the ALU, and the first is data processing perform. The second is data storage can be short-term RAM registers or long-term disk SSD, and the third is data movement, ITO operations, local device and data communications, remote system, and four is the control managed by the control unit, which interprets instructions and coordinates component operator. And the third question is a what major historical milestone define the development of modern computers. The evolution of computers started with mechanical calculators and moved to electronic system based on vacuum tubes. The IAS computer designed in the 1940 and complete in 1952 under the guidance of John von Neumann introduced the stored program concept where both instructions and data are stored in the memory. This concept became the foundation for all future general purpose computers. Go to the next questions. What defined the first generation of computers? The first generation computers used vacuum tubes for logic and memory. These machines were large, consumed a lot of power, produced excessive heat, and were prone to failure. However, they introduced the foundational concept in the digital computing, a major sample the IAS computer. And how did the invention of transistor improve computers? Invented at Bell Labs in 1947, transistors replaced vacuum tubes in the second generation. They were smaller, cheaper, more energy efficient, and more reliable. Their system introduced more advanced arithmetic and logic units, allow for use of high-level programming language, and support system software to load program, transfer data to preheaders, and manage libraries. And why are interactive circuits considered a major milestone in computer history? An interactive circuit, or can call to the ICS, were invented in 1958 and allow multi transistor to be fabricated on a single silicon wafer that reduce size and cost, increase reliability and speed, and simplify math. manufacturing. The K third generation system include IBM system to 200, 360 TAC PDB-8. This generation introduced compatibilities among product lines and start the family based on system concept. And what technology characterize later generation of computers and with LSI large scale iterations, VLSI very large scale iterations, and ULSI computer become exponentially more powerful. Innov- Innovations include microprocessors, semiconductor memory, and multi-core computers. The Intel 40 and 04 in 1971 was the first CPU on a chip, leading to the widespread use for microcomputers and later high-performance multi-core system. And go to the last question I want to show to the teachers that the whole has the Intel 86 computer evolving its introduction, and their x86 family began with their Intel 18 and 86 16-bit processor. Over decades, Intel introduced more powerful su- successors, um, 80,000 and 20 and 286 to 80,386, or can call to the 32-bit Pentium Dual Pipelines, Pentium Pro Core Xeon etc. enhancement include superscalar executions, speculative executions, multi-level cache, hybrids, threading, and multi-core processor. The architecture remain backward compatible, making it 86 one of the longest surviving and most popular CPU families. And this is the finish of all questions. Thank you, teacher, to the lecture.
Hi everyone, my name is Nguyễn Hữu Tô Hoàng, and I will take this part and I will introduce you about the cloud computing, about the IoT, about the Internet of Things system. So, the first of all, what is the cloud computing and how is defined by NIST? Yeah, cloud computing is defined by NIST as a model for enabling ubiquitous, convenient, on-demand network access to share pool of configurable computing resources. Example is network, server, storage, and application. This can be rapidly provisioned and released with minimal management or provide interaction, and cloud computing offer the scalability, cost efficiency, flexibility, and security will professionally manage data center. So, what are the key service model in cloud computing? There are three main models. The IaaS is infrastructure as a service. It offers raw computing research. Example like virtual machine. The second is PaaS is platform as a service. It offers as a platform for developing and deploying application. The third is SaaS, is software as a service. It's the more popular for the developer. It provides access to a software via the internet, example like the Google Doc, the Salesforce. Yeah. So the next slide, please. So if you research about the the cloud computing, you have to research about the embedded system. So what are the embedded system and what make them different from the general purpose computers? So an embedded system is a computer integrate into a local device for a specific purpose, like the engine control unit in car. Yeah, like the camera. Yeah. So these systems are the research constraints. Sometimes it's real time and often optimized for the power efficiencies, cost, and size. They interact closely with environment and can include the sensor, actuator, and pilot connectivity. It's called IoT. Yeah. So what is the IoT? Yeah, and how it is structured. So IoT refers growing network. It's the Internet of Things. It is stand for the Internet of Things. So IoT refers to growing network and smart device that collect, share, and act on the data. Device range from the home appliance and industrial machine. So the IoT involved through four generation is about the first of all is traditional IT. The second is embedded OT, example like factory system. The third is consumer tech, e- easy is example. Yeah, as a smartphone. Yeah, you use every day. And the fourth is the deeply embedded sensor. Is it the true IoT? You can see the smart car with the stealth drive on the car, or the camera can detect the rough that like that. So they divide you the wireless connectivity, generate the real-time data and support automation. Yeah, next slide, please. And what type of operating system are you in embedded system? Yeah, we have two approach. The first is the adapt general purpose OS, like the Linux variant, and the second develop the custom embedded OS for the real-time or constrained environment. Some support a Lincoln processor like the Enroll. Enroll is built from the Linux. It's the open source, and while the other support dedicated processor with the simpler circuits, straddling and lower overhead, like the free RTOS. So we will research about the difference between an applicant processor and the dedicated processor. So the applicant processor support full OS and can run multiple apps. Like a smartphone, on the smartphone you can run so many apps, and we have app have the native app for that smart device, like the Facebook for the iOS and the Facebook for the Android. And the second is dedicated processor are designed for just one and few specific function and are optimized for the performance, power, and cost in that narrow scope. You can use the camera to detect some rough, some people in the frame. So yeah, this assemble image processing in the camera. So this part is will be for the next person on my group. Thank you.
Hello everyone, my name is Sai. I will to talk about last question. Number one, how do microprocessor and microcontroller differ in their design and use? Microprocessor, general purpose CPU, require external RAM, ROM, and I/O used in PCS, microcontroller, or in one chip with integrated CPU, memory, and peripheral. Idea for its embedded system, example, Arduino STM32. Next, what characterize a deeply embedded system? Once deeply embedded systems are not visible to or controllable by the user, use microcontroller. and are non-program post-production, burn into IOM, perform specific tasks like sensing, basic processing, and triggering action. Example: smoke detector, and operate with extreme constraint, low power, limited memory, no display or OS. And why is ARM accepted why adopted in modern computer device? ARM is a RISC-based acceptor now for low power consumption, high performance per way, simplicity in instruction sets. It is widely and found in smartphone, tablets, embedded system, and event survive. Next, and how has evolved through its various versions, from AIM v1 and 2 AIM v9. Improvement include SAMD support AIM v6, some compressed instruction set, 64-bit processing AIM v8, trust zone security, scalable vector intention, SVI, 4AI, AIM v9, AIM now power everything from microcontroller context M to high-end CPU as context are a. Next question. What's E an instruction set structure and why E is important? ISA defines that a instruction a processor understand and how it interact with memory and I/O. It is to interface between hardware and software. Software writing for once ISA example AIM cannot run native on a processor with a different ISA example is 86 visual translation or emulation. Finally, question: what are examples of products that use ARM technology? Smartphone example: iPhone, Samsung Galaxy, Raspberry Pi, learning and prototyping, wearable, smartwatching, automated system, IoT device, AIM core are found in billions of devices annually due to their efficiency and versatility. And next minute can talk about problem.
Hello everyone, my name is Nhật. Now I will talk about the problem of the basic concept and the computer evolution. Um, about the problem one, the two computer systems implement the same instruction set architecture, but one has a pipeline CPU with a multi-level cache while the others use a simple sequential execution model with no cache. Explain how their performance differ despite having the same architecture. And although both systems share the same ISA, their organization differ. The pipeline system executes multiple instructions in parallel at different stages, uh, improving the throughput and multi-level caching reduce the data accept time. In the context, the non-pipeline systems process instructions sequentially the access data from slower memory that result in a lower performance even though the architecture appeared identical to the software. Now we move to the problem 2. The problem 2, you are asked to design a basic computer. Identify the main structural components and match each with a primary function. The data processing, storage, movement, and control. Then explain how these components work together during the execution and an instruction about the component with CPU with the ALU, the main memory, the AO modules, the control unit, the system interconnection, about the primary functions, the data processing, data storage, data movement, and the control coordination. Interaction example, the control unit feeds an instruction from main memory. The instruction is recorded and the ALU performs the necessary computation. The result is stored back in memory or sent to the AO. All of these the coordinated via the system bus. The cycle shows how the components interact and the functionality. And now we move to the problem 3. The problem 3 is a startup company need computing infrastructure for the data analytics, but want to minimize upfront the investment and maximize scalability. Propose a cloud computing solution using the specific survey models and justify your recommendation. The IIS the offer virtual machine that the company can configure for analytics. A good choice for the control and scalability. The PaaS, the abstract infrastructure allowing the developer to focus on the coding analytics and deploying the app without the managing servers. The SaaS, the Google BigQuery, the offer ready max analytic platform where the user upload the data and they get result via UI or the APIs. The recommendation to start with SaaS or the PaaS for the lower initial cost and faster time to maker. The transition to the IaaS as a system maker and needs more control customization. And now we move to the problem 4. To compare an embedded system in a smart home and one in the car's engine control unit. Identify context and real-time requirement and explain how the embedded operating system and the processor design may differ different the two systems. The feature is the contains real-time requirements as the processor about the smart most power efficient, the low cost, the short real time, the lightweight OS or the embedded Linux, the ARM Cortex M symbol MCU, the car engine control unit, the high requiability, temperature tolerant, hot real time. A missing deadline can fail again. A real-time operating system, the RTOS, and the dedicated microcontroller for the tolerance. Now we move to the problem 5. Problem 5 explains why the ARM architecture is dominant in the mobile and the IoT device. Include at the lead 3 architecture feature of the ARM and that give an advantage of the tradition architecture in these domains. First, the lower power consumption, the ARM used the RISC design. With fewer transistors and energy saving model with are the ideal for the battery power device. The second is the supply instruction set. The improved efficiency and the performance per watt while reducing complexity. The third is scalability and moderating ARM offers a wide range curve, allowing designer to select the right performance power trade-off. Uh, the, the, the fourth is a licensing model. The ARM doesn't manufacture chips, but the license is designed, encouraging the wide adoption and customization by the companies like Apple, the Qualcomm, and the MediaTek. The result, the ARM is due in a billion of devices annually due to its flexibility, power, efficiency, and the performance balance. And that is of my growth. And now, thank you for listening. Okay,